All right, Wildcats. It looks like there's a little bit of a delay. Not sure I like that. But I'm going to share my screen and see how it goes. Okay, let's go. Let's see if we can find the note sheet. It's a little late. All right, we're going to try this anyway. All right, so first of all, what page am I on? The wrong page. Let's go. Okay, so this is, I think, page 9. Page 9. And, well, you know what? I'm going to, 1, 2, 3, 4, 5, 6, 7, 8. I want to give you a preview. This is where we're headed. This is page 17. See those 4 triangles? They all have a different name. Well, actually, the names are these dots. Like this is the circumcenter. This is the incenter. This is the centroid and the orthocenter. They look from a distance, these 4 triangles all look the same. So the challenge is going to be, Wildcats, can you figure out what triangle applies in any given situation? Okay, and here are some hints. This gold dot is formed by perpendicular bisectors. This gold dot is formed by, I would like to get rid of this. Yeah. This gold dot is formed by angle bisectors. This one is formed by medians, and this one's formed by altitudes. You can read down here a little bit about them, but that's a preview of coming attractions for real. We're just going to talk about this triangle today. It's called the in-center triangle. That's the one that's on page 9. So let's go back to page 9. Perfect. Now, this isn't what yours looks like yet, but that's what I want you to do. I want you to listen as I describe what is being done here, what has been done. PL, locate PL, this line right here. That is an angle bisector. How do I know? Look, the angle at P has been cut in half. See the red arcs? And that means that's an angle bisector. So let's go. I have also written, and you should write this too, those are the names of the angles that are now equal with those arcs, the red one and the blue one. And I've written down that PL is an angle bisector. You should write that too. Okay, write this, an angle bisector. This is what it does. The definition of angle bisector is congruent angles are formed. Angle bisector implies congruent angles. Okay, so now we got to talk about, let's talk about these other lines. Well, I have the angle bisector here at P, but I want you to also, you don't have to draw these, but this green line and this gold line, just look at them, all right? I decided I was going to just say, look at angle Q. I split that in half so that the green line is also an angle bisector. And I did that at R too. Look, R has been split in half. That gold line is also an angle bisector. Okay, so now you know where the 3 converge. They call it a point of concurrency. Go ahead, say point of concurrency. I can't hear you. Crickets. Well, that is an in-center. And that's the star of the show today, that gold dot. Because when you have a gold dot like that in the middle of a triangle, and it's called an in-center, look at all of the matches that happen. Please take a time and pause the video and record all of the matches you see here, the tick marks as well as the angles, and don't forget the right angles. Pause the video, do it. Okay, so you've unpaused the video. And let me just make some observations. Be a noticer. We always talk about that. Be a noticer. The in-center, this gold dot, is the same distance to the sides. Look, that's what these 3 red lines and the tick marks mean. That's the distance to the sides. Now, that's different than this. This is the distance to the corners, right? So look, there's no tick marks on these segments. These tick marks, there's no tick marks here, right? We're not talking about the distance to the corners. Write this down. You're talking about the distance to the sides. That's a special property of an in-center triangle. It's not going to be a property of any of the others. The other thing to notice is look where these matches are, all right? They are around a corner, like this is around corner A, and look at the 2 tick marks that match around corner B, and these match around corner C. And not too surprising are all the angle congruences at the corners, because that's what angle bisectors do, right? So there. All right, you got all those. Oh, pay attention. Look at these little cool little markings. There's arcs there and tick marks, just because this triangle's so busy. Okay, that is the star of the show. And that's all we're going to do on page 9. Because now I want you to go to the, just notice that the practice for the incenters, first of all, page 10 is all incenters. But 15 and 16, there's incenter problems in there somewhere, and it's a challenge to figure out which ones they are. Okay, so you'll look for the word incenter or the word angle bisector or markings that angles are congruent in the corners. And those are your clues that this is the triangle that applies. And then all of these markings apply. All right, one more thing to write. It's all right there. The incenter is the intersection of 3 angle bisectors. All right, pause the video, write that, and then turn the page. All right, Wildcats. This is page 10, the top of page 10 on the left. And actually, this triangle's, I've already marked it all up, but yours isn't. Why don't you pause the video and see if you can not look here, just here, and use the triangle we just did on page 9 and see if you can mark it all up correctly. Do it. Okay. All right, is this what yours looks like? Maybe you're missing some of those letters too, but okay, that is an in-center triangle. This is a dead giveaway right here. You got this, right? And look, around the corners are matches. You got angle bisectors in each corner. Okay, so that's an in-center triangle. All right, now on the next triangle, the one right down below, do the same thing. Go mark it all up. See if you got it. It's not a test. Pause the video. Okay, as yours look, oops, there's some numbers on here. Let me get rid of some of these. Let me get rid of all this stuff. Just check that you've got all of the correct markings. So it should look like this. All right, you got everything? Did you forget? Oh, I'm a slacker. Look, these should be right angles here. Look, right here at T. You got another one there, another one here. Oops, I'm out of room here. There. Look, the triangle's so busy you don't have room for everything. All right, that's a good thing because you can do more with less when you have all these markings. So now what? Well, down below, there's some information. Look, we're going to look for TF. They're telling us SP is 3. What does that mean? Let's go find SP. Oh, SP is right here. This is a 3 then. Look where I wrote that, right in the middle of the segment. Don't put the 3 here in the corner, right? Don't put 3 here. 3 belongs right in the middle. That's where the tick mark belongs too. Let's put in the other 3s, right? Because these are a match. Okay. And notice I have gold highlighted the TF segment because that's the one we're looking for. I want to focus on that. All right. And then, all right, what that? We got a PF is 5. PF is 5. Okay, so that's the blue segment. So I'm going to put a 5 right here. Oh, well, how convenient. I could show off and put a 5 here because, oh no, that's not a 5. My bad. What am I talking about? Okay, I'm talking smack up here. I want you to focus on this yellow triangle. Why is that a good focused triangle? Because you know the 3 and the 5, and you're missing the gold line. That's what this is the one you're looking for. You're looking for the one TF. And how do you get that? Well, that's the right triangle. This is how you do that. Now, how did I know to subtract? How did I know to subtract 5 squared minus the 3 squared? How did I know that? It's because this segment here is opposite the right angle. That's the hypotenuse then. If it's the hypotenuse, then this is going to be a subtraction, not an addition. All right, so 5's the answer. You're done with that problem. All right, before I go, I want you to write out, these are the things that will help you be successful, people. First, always mark up the triangle completely. Second, put in the given information, like the 3 and the 5 that we had, all right? Then record any matches that might exist, like all the 3s, there were 2 more 3s, right? Then find any missing measures and label all the repeats after that too. Okay? There it is. That's the process. And before I go, I want you to copy this down. Copy that in that space right there. All right, Wildcats, you know what to do. You know where to find me. Okay, let's go.